Alicia.
Oh, come on. It was right there. It was right there. I know, right there.
Hi. Hello. Sorry.
These.
We should have a pointer.
Christmas.
That would be.
How do you have storage for this?
Okay, so we did some geometry yesterday. We'll do some more geometry today.
Oh, really?
We'll do.
Bad action.
We've started. We ended at number 24, so we'll do number 25. Plotting a polygon. Right.
I think.
So, plotting a polygon. Right. Do I have any graph paper?
I can't.
Class?
What are we on? For this, it sounds like we
Yeah, you might as well get some graph paper out. You got it.
No.
Oh, do you can make
I don't like
like
graph
a job?
paper.
Alright, calm
We're on
down, calm
number
down.
24, right?
Set
24?
your
Okay, right.
What number?
Number
25.
25.
25.
Alright, well.
25.
Say it again. Say it again.
Impressive.
Say it again.
25.
Nice.
Alright. So, number 25, right?
Correct.
Plotting a polygon.
Yeah. Nice. That was Jimmy's work.
Did you see that, Rebecca, or is that too light?
I mean, it's a little light. But
You sure you know you're my project?
Would you rather even black?
History?
It's still a glare.
No, it's just
The glare.
it's actually light.
It goes the way.
Look at that red marker.
So you can't see that red right there.
Yeah,
Too
I
black.
can see that light right there. That light red. That's regular red. That's light red.
Okay, plotting a polygon. I mean, this part of the process is fairly simple.
Fairly.
What about if I use green? Would green be better?
Wow, Christmas spirit.
That was so funny.
Josh is making fun of something.
Getting green.
Yeah, Rebecca?
Yeah.
The what?
And then you open that.
Okay.
Put a plot.
Ow.
I suppose I could do that.
Oh, I thought that too.
Oh my god.
Alright.
Like the
Got
one.
a white bar?
Calm down. Change green now.
So, polygon, right? Closed figure, straight sides connected by vertexes. Right? Okay. So if I'm plotting a polygon, it could be any kind of polygon, right?
Yeet. Huge. Hendrix. Hendrix.
That was so cute.
What was that, dude? Hendrix.
Kevin's learning.
Oh, you guys were open too? Yeah,
What
alright, alright.
is that? Does everyone agree that this is a polygon?
Yeah.
Yes, sir.
Alright.
I do agree.
So
I haven't even
points
seen it. Yeah.
are 0, 0, 2, 1, and 1, 4. Okay.
One, two, three, four.
I can't write anymore.
There you go.
I can't.
Get better.
Okay, now, we plotted a polygon, good. Next, transforming, rotating, and scaling a polygon, okay? Transforming and rotating are the same things as you can do for points. You just treat each point individually, right? So if I shift to the left, I just shift every point to the left. If I reflected about the x-axis, I reflect every point about the x-axis, right? So the same thing that we covered yesterday about transforming a point, we just do with the points on the polygon, right? Okay. That being said, there is one part of it, scaling a polygon, which is a little bit different, if you remember.
Yes.
So if I want to, welcome back everyone, round of applause.
Where are you?
Now she's like,
Late again. And there goes.
Okay. So if I'm scaling a polygon, What do I do?
Oh, isn't it like
I'm
that?
gonna scale it,
Sorry,
right?
I had a little
Yeah,
bit.
I'm gonna scale it.
I had a little bit of trouble with this one, sir.
You just feel it.
You just scale it. You just feel it out.
Oh,
You just kind of go with
I
it.
used to have trouble.
All right. Look, this is what you do. You start at a point. Whichever point doesn't matter. I'll start at this point. 0, 0, and I scale from there. Okay. Say I want to scale it with a ratio of 2 to 1. Okay. So my ratio is 2 to 1, so I want to make it twice as big. So this is what I do. I start at this point, and I see how much I go over. I go over 1, 2, and up 1. So if I'm scaling at a ratio of 2 to 1, I'll go over how many? 4, and up how many? 2. Does that make sense? Over 4, up 2.
I see. So wait, you went by that point 2, 1? Is that what you went by?
Yeah.
So you just times the 2 points by 2, right?
No.
No.
Because it's not always going to be that way. That was only the way that is because it's at 0, 0. I don't always multiply the point by 2. I multiply how much I go over and up. So I go over 2 and up 1. So I'm going to go over 4 and up 2. Right? Does that make sense? Okay. Then I go to this next point. Here I go over 1 and up 4. So I'm going to go over 2 and up 8.
Nice.
Over 2 and up 8.
Nice. That'll do it.
And then if I draw my new polygon, that'll be it. Does everyone feel pretty good about that?
Yeah.
But not always. I don't always just multiply the points by 2. I multiply how much I go over and up by 2. Does that make sense? Let's see. I'll show you one that you don't just multiply by 2. Okay? For instance, what about if I start here at, or let's say here. Okay. In this polygon, I don't have any of my points of origin. I have it.
Hey,
Can't see, sir.
can't see. I can't see.
What is that?
Can't see.
What's that?
It was a hiccup.
I'm not back.
No, you're just not past it.
Yeah, that's we're talking about something else already. No. The star of the Christmas tree.
So what are the points for this thing?
So -2, -2. This point is 1, 1. This point is -2, +2.
Right.
All right.
Oh,
No.
Yes, there's
-2, +2.
These.
1.
1, 2, 1, 2.
Hey.
Hey.
I don't care.
Let's just bring it down a notch before something
Alright.
gets out of control. There's a lot of stains in this carpet.
I know, it's green too, isn't it? Go to school. What are they?
Oh, that's how the old always used to look, by the way.
Supposed to be red?
Yeah.
They didn't used to look like that. Just like that.
Do they get new carpet?
No, it was like a few.
I don't like carpet. Carpet stinks. Literally, it stinks.
Okay, so
Somebody hates
let's
carpet.
choose a point. Does it matter which point we choose? No, let's choose this point. Usually I choose this point. Let's choose this point.
Alright.
Okay?
Okay.
Okay, so from this point to this point, I go to the left 1, 2, 3, and I go up 1. So I should go to the left how many? 6. And up how many?
2.
2.
One.
Very good.
Wow.
So there's my new point here.
Where's it again?
I went over 3, 1, 2, 3, and up 1. So now I need to go over 6 and up 2.
Okay.
Right?
These.
Now, to get to this point here, I go over 1, 2, 3, and down 1, 2, 3. Right? So I should go over how many? 6, and down how many? 6. Very good. And then I connect my points. Guys, get the point?
Hilarious.
Thanks. Thanks.
I want cold stone.
Now, remember, this is only if the ratio is 2 to 1. If the ratio was 1.5 to 1,
No.
Oh.
Don't do that.
or if the ratio was 3 to 1,
No, don't do that.
yes,
Why 6?
because I went over 3, and so I have to go, since the ratio is 2 to 1, I have to go over double. Does that make sense? Right. But I'm not multiplying the points. That's what I was saying here. I'm not multiplying the points by 2. I'm multiplying the distance that I travel. So I go down 3 and over 3. So I need to go down 6 and over 6. Got it? Yeah? Yeah? Because the distance between these 2 points is what I'm doubling. Not where the distance between the point and the origin, right? I'm multiplying the distance between the 2 points. So instead of going over 3 and down 3, I go over 6 and down 6. That's right. Okay. Now, just a quick run over of this. Similar polygons are what? Similar means
Same angles.
No.
same shape. Congruent
Yeah.
means what?
Same
Same size and shape.
The same shape.
Did you say to me? No, it's you.
Same size and shape. Right?
Yeah.
Cool. Very good. My goodness, we learned so much.
Triangle.
Next.
Do we have to know anything in particular about similar congruent polygons or no?
Similar, same.
Just knowing that they're the same like shape. For instance, if I scale 2 polygons, if I scale a polygon, are the 2 polygons congruent?
Yeah. No.
Are they similar?
Yeah.
Same shape.
Yeah.
Triangle D's.
Triangle inequalities.
Yes, sir.
If this side is 4 and this side is 5, give me the limits of side x. Do that on your paper now. What's the range of x?
Alright.
Okay.
Hmm?
Is it 3, 4, 5 triangle?
No.
No. When you do that, when
What's
five
the
is
range
that,
of x? X can be between a certain set of numbers.
Oh, I remember this.
You guys remember this?
Okay. Wait, the other way. How is it the other way? What did you give me? How can it be more than 1 times?
All right.
That's a good observation.
Who's got the answer? X has to be greater than what?
1.
Y.
And because
5 minus 4.
Has to be greater than 5 minus 4. Good. It has to be less than what? Could it be less than or equal to? No,
It's
less
greater
than.
than it's greater than the difference.
Okay, that's the main concept there. Alright.
That's true though. Okay.
Perpendicular bisector. Okay. If I have a line, segment,
A's
I have a line segment
perpendicular.
A, B, and I draw a perpendicular bisector. Okay. Let's say bisects it at point C. What do I know about lines AC and line CB? They're
Equidistant.
congruent.
And congruent.
Okay. So perpendicular bisector bisects the line, right? We've gotten familiar with the word bisect, I think, at this point. It just means it splits it into two. What's the prefix bi? What does that usually mean? Two.
Bicycle.
Bisect. Right? What do I know about any point along the perpendicular bisector? Say I've got this point D on the perpendicular bisector. What do I know about that point? What do I know about it?
Is it equidistant?
It's the same distance from A
As it is to B.
as it is to B,
Nice.
right? That's congruent with that. Cool?
What you talking about?
Remember how much fun we had in the beginning of the year with those guys?
Yeah, and I was
Remember how much fun it was to just basic geometry? That was so much fun.
Chick-fil-A sauce.
Alright. Remember Mr. P, Dr. D?
You're
Yes.
you're making Chipotle.
We should have made him Dr. D.
Everything
Yes.
about Chipotle. I don't think you were here.
It's okay.
We
You were in our hearts. You just hadn't arrived in person yet.
So you did not use
Your
the
spirit was here.
Oh, that's right.
Alyssa was in our hearts from the very beginning. Remember what her first day class?
Yeah.
I remember that she had a shirt.
Oh my gosh.
This is not a hobo.
And she made me, she didn't let me.
What is she saying?
He was saying hi, but now he's just saying hi.
And
Alright,
then,
got it?
like,
Good.
remember on the-
Class, perpendicular bisector. What else do we know about a perpendicular bisector?
Oh,
It's
right angle.
Right angle.
perpendicular, right?
Perpendicular.
I mean,
Right angle.
Right.
No, perpendicular.
Okay, so if this side was x plus 2 and this side was negative 3, this side was 3, solve for x. And if this side was y squared and this side was 9, what's x here? X equals 1 and y would equal what?
Bless me when I see
3. What else could y equal?
I have a paper for
Y
you.
could equal negative 3. Be careful. Plus or minus. Do you have? Oh, okay.
Can I give you this now?
Thank you. I thought you were going to grab one of the students.
no, that's.
You should take me.
TJP. I don't think you read it now.
Good job, that'll
You just know. Negative.
What is that? But
You look like a little mini genius over there. I
I've
understand
not-
now.
She started.
I understand now.
This thing is useless to me.
Your inner genius radiant child is coming out.
He's like, let me teach.
You can teach. Any of you guys can teach at any time. You guys want to teach today?
Sure, let's do it.
Yeah, no.
I need to fail this thing.
Alright. Perpendicular bisector. exterior angles.
Oh.
Exterior angles of a polygon.
Exterior, it's a good part.
There's
Your exterior.
Okay. This is the exterior angle, theta. Okay. Now, let's say this is phi is my interior angle. Okay. What's my equation for the interior angles?
180 times n minus 2
180 times n minus 2 over
n.
n. Now, what do I know about theta and phi in this case?
Oh.
They're supplementary. So I know that theta plus phi equals what? 180, right?
Oh.
What's
What's that thing with the
phi?
line?
I apologize. I just made phi my interior angle. Phi is this.
Okay, yeah, but
Oh,
what is
what is
that?
that?
What does that mean? What is
Okay,
that?
I'll just make it X. It's a Greek letter. It's a Greek letter. It's just a Greek letter.
Alright, Greek letter that's sticky.
Phi is just phi. It makes the PH sound in the Greek language.
Oh, we're not in Greek.
The more you know.
It's also very often used to denote angles.
Really?
Yes. Okay.
X.
So x equals 180 times n minus 2 over n. Theta plus x equals 180. Right?
No.
Theta makes the sound in Greek.
What?
All right. So now I want to solve for theta, right?
Yeah.
So I subtract x from both sides.
Okay.
I get theta equals 180 degrees minus x. Right?
Yeah.
Then I plug that in here. I say theta equals 180 minus 180 times n minus 2 over n. Right? What? I'm just deriving the equation.
Just try it, right?
Okay, so I want to add these fractions. How? I want to add these together. What do I have to do?
Take out.
How do you get 180 minus 180?
This would be like 180 over 1, right? I multiply by n, right? So I make this times n over n, right? And this becomes 180n minus, distributing this in, 180n minus, it's minus a minus, so it's plus 360 all over n. What? When? How?
Man, if I could only see what was going on.
Yeah. Don't worry too much. I'm just deriving something. You guys all agree that I did math here, right?
Yeah.
And math works as long as I say it does.
Yeah.
I mean, not me, but just as long as we agree that it does.
As
As long as we agree that math works, then math works, right? Agreed? Do we agree that math works?
Maybe.
Yes, but if
All right.
we be wrong, it's
We'll
like,
talk about it later.
yeah.
But the point is that all the math was correct here, right?
Yeah.
Well, I'm pretty sure.
All right. I eliminate 180n minus 180n, and I get 360 over n. There you go.
Alright.
The formula for finding the exterior angles of a polygon is just 360 over n.
You're gonna have to know how to do all that algebra you
No,
just did?
just
Okay.
remember 360 over n.
What's that the formula for?
The exterior angles. So theta equals 360 over n. So for instance, if I have a triangle, how many sides do I have? 3. What's the measure of my exterior angles? 1.
20.
120 would be 360 over 3 would equal 120, right? Okay. What about on this one? I have 6 sides. So it would be 360 over would be 60 degrees. Does that look like it could be 60 degrees? All right. So those are your two functions, okay? The way that I can remember them is like theta in is 180 times n minus 2 over n. and theta out, or exterior, theta exterior is equal to 360 over n, okay? Those are your two equations. Now, class, if you can't remember the exterior one, then just figure out what the interior one is and then do 180 minus that. Right?
Okay.
Same deal, same difference.
Same D's.
Okay.
How you doing, Charlie?
Exterior angles, done. Now,
Charlie?
that being said, I could always add algebra in there, right? Right? I could say, okay, this then equals, 4x plus 2 or something, right? Or 4x plus 20. And what did I figure out? This angle was 60, right? I used my formula to make it 60, so I say 60 equals 4x plus 20. Subtract 20 from both sides. I get 4x equals 40 divided by 4, x equals 10. Right? I could always do something like that. But the concept is just the exterior angles.
Sir, where did you get 60?
Because if this has 6 sides, then the exterior angle is 360 over 6. So this would be 60 degrees. Right? Is everybody with me on that? Yep.
Okay.
Okay, look at that. 30 done. 31.
31.
Bom, bom, bim, bicka, bom, bom, bim. Bicka, 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 bom, bim. Bom, 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 bom. 31.
I got another paper out.
Isosceles triangle.
Dude, this kid is so stupid. Isosceles triangles.
I had a friend.
Yeah.
She was like from a different country, and
Are you gonna compare it?
and her name was, it was kind of like Sally, but it was Sally, and she had these really awesome designs that she made. That they were like these triangles, and she invited me over to take a look at them, and it was really nice because when I went over there, I saw Sally's triangles.
Wow. I've been trying to make up a joke. I thought you were telling us a story.
I'm so done. I'm done.
I thought I saw the lights down there.
Yes, that's right. Take that shit. Okay.
Wow.
Oh my
No,
gosh.
I apologize. It's okay. No, it's okay. It's okay. It's really fine. It was very moronic. Is probably the way to say it.
You're quite amazing.
Thank you. All right. Thank you. All right. We all win for the day, I think. Okay. Isosceles triangle. What do I know about an isosceles triangle?
Who's that?
Mr. Mayor,
Two
you sound
sides
like
are
Elvis.
congruent. Was that?
Do you sound like Elvis?
Yeah, serious.
I don't think so.
Try. Can't even imitate you.
That's probably the best I could do. All right. So isosceles triangle, two sides are the same, two sides are congruent, and two angles are congruent. All right. I'm not gonna give you. I'll let you know so you don't stress out over it. The really complicated isosceles triangles proofs. Those were.
Sorry,
I'm not gonna give you that.
Thank you.
Um, Those were too complicated, and I don't think they really helped you develop an understanding of isosceles triangles at all. This is an isosceles triangle. What's an equilateral triangle?
Oh.
Triangle.
All sides are congruent, and all angles are congruent. Right?
So what do I have to know about this?
You just have to know them. You have to understand them.
I'm not doing what?
You gotta believe in them. Okay. Next. So, triangle proofs.
No.
Okay.
No. No. What?
Triangle proofs. Okay. I'm gonna put one up on the board, and then you're gonna prove it on your own paper.
Oh no,
Stop. I don't.
it's an hourglass.
Did you just say? Oh.
Okay. Given. Side AC is congruent to side CD. Side BC is congruent to side CE. Prove that triangle ABC is congruent to triangle CDE.
Okay. Oh my god.
How many steps are there? Like, how long is this
I
gonna
don't
be?
know. There's many different
Like,
ways
should I
to do
start
it.
it on another day?
What was that? Yeah, maybe. It's only gonna be 5 or 6 steps.
Yeah.
We got enough room.
Okay.
Okay.
Don't lie, do things that way.
You will love mathematics.
No.
You will love geometry. I think it does work actually. It's like, yeah, suggestion. There's something called neuro-linguistic programming. You can get people to do all sorts of weird things.
What's it called?
Just like a little bit.
What is it called?
Neuro-linguistic programming.
Like the hypnosis or something?
Hypnosis.
Like when you hypnotize someone,
It's just
You completely messed that up. That was
you
your.
have to.
But I mean, you can do that to yourself without really being all weird about it. You can just be like, I love math. And just continuously say that to yourself. Every time you, while you're brushing your teeth, just, I love math, I love math, I love math, I love math.
You can do it to yourself in a weird way.
Just
Do while you're doing the dishes. You're like, I love doing the dishes.
steady beats.
You guys moving forward on this?
I need 4.2 steady beats. So gay. 9
No, it's not a midpoint.
ruin your life. Just trying to deliver truth.
Okay, we're done. We're done here. Do your food. No, you did not do that. Let's see. Out of your bag.
Attention please, attention please. The varsity game for today has been changed to 3:30 p.m. Teachers, please dismiss these players at 2:15. Also, middle school basketball practices for today have been canceled. Thank you.
Which varsity sports we are? Which varsity sports are we?
Okay. So, statement, reason. Okay. First is just the givens. What comes next? I think that just happens in this class, specifically so you comment on it. See, I told you. Joel, what do you have to say about this?
These. What are you doing, Joel? These. What are you doing?
She's in
Do your work.
Ecuador being cool and
She is in Ecuador being cool.
not here.
What do you mean? This is the best place on earth.
Not studying at all.
Think about it.
Just said you were studying.
These.
So what's the second? What do we do next?
Well, I think a C is the point.
DCE.
Vertical. It's not the midpoint. What?
Vertical angle.
Which angle?
ACB and
Angle ACB
Mm-hmm.
is congruent to angle DCE. How do I know how to name the angle?
Those are two.
C has to be in the middle.
C just has to be in the middle, right? And how do I know that they're congruent?
Vertical
Vertical
angles.
angles. Yeah. If C was the midpoint, then this side would have to equal this side. And this side would have to equal that side. Because if it was the midpoint, they would be equal on either side. Alright. Once I know those angles are congruent, what do I know?
Triangles congruent.
Triangle ABC is congruent to triangle CBE. Why? Side angle, side, triangle. Alright, so I hate to be an ending giver,
A what?
When you give something and then you take it back.
which is really actually completely a misnomer, because in native peoples, like they don't give straight on them.
Indeed,
I don't know why that could keep that.
Well, maybe some of them didn't.
True.
Oh.
Wow.
Why can't it be angle C?
Jeez. For real. Just did it again.
Because saying angle
Thanks,
C in
Raquel.
class, good question. Why couldn't it just be angle C is congruent to angle C? Right? Because that's not specific enough. Because if it was just a triangle like this, and I said, oh, that's C, then I know what angle C is. But since it goes out like this, then this is just a point. That could refer to this angle here or this angle here. I have to give the 3 points. Good question. All right. So,
Oh, that's divine. Are you talking about it?
No.
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 Sure, they love making fun of me.
It's not you. It's me. Oh, what are we on?
You smell that? Smell it too.
given
Oh, so.
angle ABD is congruent to angle CBE, and angle ABB is congruent to angle BEC. All right? And triangle DBE or BDE is isosceles.
Alright.
Prove that triangle ABD is congruent to triangle BCD. Anybody on it? All right. Statement, reason. One is obviously given, given. Okay. What's next? BB is congruent to BE. How do I know that? Right. If this is an isosceles triangle, those two sides are congruent, right? BB is congruent to BE because it's the definition of isosceles triangle. Once I have that, what do I have? The triangles are congruent. Triangle BCE. How do I know that? Angle, side angle. Triangle congruent. Very good. Now what if I said to you, prove that side AB is congruent to side BC? What would you have to do? I wanted to prove that this side is congruent to that side. I've already proved that the two triangles are congruent. Right. I would just say next step, my next step would be side AB is congruent to side BC. Why? Corresponding parts of congruent triangles are congruent. Got it? Feel pretty good? Yeah? Good? Understood? Okay. Can also give you the last one for the day. Give you something like this. Like this, where I say, given side BC is congruent to side DE, angle D, now Priscilla, in this case I can just say angle D. See? Angle D is congruent to angle C, and line P is parallel to line Q. Prove that line EA is congruent to line, or EF, I apologize. EF is congruent to line AB. So I want to prove that this line is congruent to that line.
So long one? No.
So long. By the way, you don't have to use just like vertical angles or corresponding angles. You can use whatever theorem you want to use for this one. Okay. In interest of time, I'm going to go over it. The first one, just given. What's the next thing I know? What do I know? Is there anything congruent? Anything? Right. Angle DEF, or I could just say angle B and angle E are congruent, right? How do I know that? Alternate exterior angles. You guys got that? Alternate exterior angles theorem. Well, and once I know that those two angles are equal, right? I know this angle is equal to this angle. And trust me, it helps you to just draw that in the picture. What do I know? Triangle DEF is congruent to triangle ABCY. Angle, side angle, triangle congruence criteria. Now, I'm not just looking at the triangles are congruent. What am I looking for? Right? So how do I know that they're congruent? How? Okay, good. So EF is congruent to line AB, Y, CB, C, line face. Good job, class. Good work, Joelle and Ecuador. And I highly recommend that you go over this review sheet, and because a lot of this stuff is fairly recent that we've been doing. So see what you really have questions on, so then on Monday we can really highlight it, because it's a lot of material. Okay? Understood? Say goodbye to Joelle. Bye, Joelle.
Hi.
Peace.